Okay. Some things that I want you to be aware of on Canvas. There's lots of information on Canvas. There's homework solutions. You'll have your Chapter 6 homework solutions today. There's your test, your homework, your final exam dates. All that's published on Canvas. Test and final exam reviews are coming soon. Your test your test review will be up today. Your final exam review will be up by the end of the week. Okay? The other thing is there are videos for Chapter 6 up there. Now, if you need videos from Chapter 5 or Chapter 7, you've got to go back a couple of weeks' announcements. They're there. You just have to go back. Okay? So if you can't find exactly what you're looking for, go back to before spring break. You'll get your Chapter 7 videos. Go back to a week or 2 weeks ago, and you'll get your Chapter 5 videos. Chapter 6 videos are up under this week's announcement. Okay? So, be sure to check Canvas. Lots and lots of good information on Canvas. Now, we are going to start talking about some solutions that are not rational. Now, both of those solutions up there, they had irrational solutions. And an irrational number is a number that's inside a square root. Okay? That's what an irrational number is. That just means that it can't be a fraction. It's not a whole number. It's inside the square root, and it cannot be simplified further. That's what an irrational is. And our answer to this one right here is irrational. Irrationals still cross the x-axis. So both of these up here, if you had graphed them, they still would have crossed the x-axis. You would have had to estimate where the solution was. But I do want you to know that they still cross the x-axis. So this one right here is just x squared equals 45. Now, if this was x squared equals 16, we would just take the square root of both sides, and we would have what for our answer if it was x squared equals 16? 4 and negative 4. You're absolutely right. X equals 4 and x equals negative 4. We're going to use that same process here. It's just not a perfect square. Okay? So what I'm going to do is I am going to take x squared equals 45, and I'm going to take the square root of both sides. Now, when I take the square root of 45, what do I have to put in front of it? Plus or minus. Okay? Plus or minus. So then I end up with x equals plus or minus 45. Now, there is a perfect square in 45. Anybody know what that perfect square is in 45? Yes, it's 9. So I have x equals plus or minus 9 times 5. Okay, can I take the square root of 9? I can. I can take the square root of 9. The square root of 9 is 3. So I'm left with x equals plus or minus 3 on the square root of 5. Okay, that's my solution. I've got two solutions, plus 3 on the square root of 5 and minus 3 on the square root of 5. So this is my final answer right here. This crosses the x-axis. This crosses the x-axis. Okay? It's very difficult to tell where it crosses the x-axis because we are estimating it because it's in between two numbers. Okay? Now, I want us to look at a problem that does not cross the x-axis. When we get a solution, that solution is not represented by crossing the x-axis. So can I move off the screen? Okay. So I have a very similar problem here. It's x squared equals negative 9. Okay? X squared equals negative 9. If you had a calculator and you tried to take the square root of negative 9, it would say no real solution. Okay? And what that means is it's not going to cross the x-axis. It's not a rational solution. It's not real. There are no two numbers that I can multiply together that will give me negative 9. So think about it. Okay? If I do negative 3 and negative 3, what do I get? If I do negative 3 and positive 3, those are not the same number. So there are no real number that I can multiply together that's going to give me negative 9. So if I wanted to take the square root of negative 9, I would get no real solution. Okay? So what has happened right here in this graph doesn't cross the x-axis. Do you see how this is the x-axis right here? And here, I've moved it up. I'm not crossing the x-axis at all. So I can have a solution to this. It's called a complex or imaginary solution. But when I get that solution, it's not crossing the x-axis. Does anyone know what allows me to solve this? It's an imaginary number. It's the most popular imaginary number, and you probably learned it about Algebra 2 in high school. It's okay if you don't know.
Is it the little I?
It is the little I. It is the little I. Okay? So, because, and the little I is not real. Okay? It is an imaginary number, a complex number. Okay? So, little I is the square root of negative 1. It is a way for us to simplify the square root of negative 1. So in this problem right here, I have x squared equals negative 9. I'm going to take the square root of both sides, and don't forget our plus or minus there. And so I'm left with x equals plus or minus the square root of negative 9. I'm allowed, because of the properties of I, and I is a number, it's always the square root of negative 1, to break this up. So I can break this up into negative 1 times 9. So I can simplify this right here. This negative 1, if I take the square root of negative 1, it becomes I. What's the square root of 9? 3. Okay? So my answer to this problem right here is x equals plus or minus 3i. That is my answer. Now, notice it does not cross the x-axis. Here's the x-axis right here. Do you see the x-axis? I'm not crossing the x-axis. I am above the x-axis. You can also have it to where you're below the x-axis, depending on how the problem is written. Okay? Whenever we use I, whenever I is part of our solution, okay, when I is part of our solution, we don't cross the x-axis. Okay? So now what we're going to do is we're going to practice some of our properties with I. When I is part of our solution, we do not cross x-axis. Okay? So that's what you need to know about I. So let's talk a little bit about the properties of I. Okay? Can I move off the screen? So I is the square root of negative 1. That's what you need to know. So in this situation right here, where I have the square root of negative 4, what you are going to do is you are going to break that down to negative 1 times 4. Negative 1 times 4. What is the square root of negative 1? I. And what is the square root of 4? 2. So my answer here is 2i. Okay, now we don't have to put the plus or minus in front of this because this is just asking us for the square root. The times that we do put the plus or minus is when it says x squared equals a number, okay, we don't know what that number is, but when x squared equals a number, that's when we put the plus or minus in front of it. Okay, if the square root is given to us, we don't have to put the plus or minus in front of it. We only put the plus or minus in front of it when we add the square root because we've got x squared. Now, look at the next one, negative 17. The square root of negative 17. I can break that up into negative 1 times 17. What's the square root of negative 1? I. Can I take the square root of 17? No. So this is read I on the square root of 17. I on the square root of 17. Some people in some books will write square root of 17 I. I do not like this way. I would prefer you not to write it that way. Because while this is correct, what students end up doing is they end up doing it like this. What's the difference between those two? I is under the square root on the bottom one, and you don't want that. So I would recommend not doing that. While the top one is correct, the bottom one is not. And sometimes you guys just get so fast with your writing that you don't realize you've put the I inside the square root. So I prefer it written as I on the square root of 17. Okay? Now, for this negative 24, I've got to break it up a little bit more. I've got negative 1 times 4 times 6. Why did I break 24 up to 4 times 6? Because 4 is perfect. Okay? So, I'm going to take out the square root of negative 1, which is I. The square root of 4 is 2. Can I take the square root of 6? No. So I am leaving the square root of 6 in the square root sign. So this is read 2I on the square root of 6. And these problems right here are to help you solve completing the square and quadratic formula problems when our graph does not cross the x-axis. Okay, that's what's happening right here. Okay, can I go to the next screen? Okay, this is just a quick addition problem, or it's actually subtraction. I want to just remind you that I is going to follow the same properties that x does. And so we are going to distribute this negative right there. We're going to distribute that negative. And then we're going to combine like terms. So I have negative 6 plus 4i. Then I'm going to have negative 8 plus 7i. Negative 6 plus 4i minus 8 plus 7i. Now I can combine like terms. Negative 6 and negative 8 are like terms. Then I have 4i and 7i are like terms. Okay. I cannot combine negative 4 and 11i because they are unlike terms. You treat it the same way you would treat negative 14 plus 11x. Could I combine negative 14 and 11x? Could I combine those? No, because they are not like terms. I can't combine them. Therefore, I cannot combine negative 14 and 11i. Okay? Okay. Can I go to the next screen? Okay. I am actually going to solve this problem using completing the square and the quadratic formula. I'm going to give you 3 minutes to do one of them. Shay. This is your correct answer right here. Negative 4 plus 11i. Okay, I am giving you 3 minutes. You can solve this either way. You can use the quadratic formula or you can use completing the square. I'm going to do both. I am going to solve this using both. Okay? Okay. Okay, I'm going to do completing the square. And remember, on your final exam, there is one problem that says solve by completing the square. Okay? There is a problem on your final exam that says solve by completing the square. So, I already have this set up to where it's equal to 0. Okay? It's already set up to where it's equal to 0. So, I am going to move my 19 to the right because I have to have my x squared and my minus 2x on one side, and then I'm going to have my 19 on the other. But I have to do the opposite. So what am I actually doing? Subtracting what? 19. So I have negative 19 over here. Okay, now I am going to take half of negative 2. What's half of negative 2? Negative 1, and square it. What do I get? Good. So I'm adding plus 1 to both sides. Okay? So I factor x squared minus 2x plus 1. Okay, that factors to x minus 1 times x minus 1. And we can rewrite that as x minus 1 squared. That is by design. We want it to be a perfect square trinomial. When we took half of b and squared it, we created it as a perfect square trinomial. That's what we want to happen. Okay, our next step is to take the square root of both sides. So I've got plus or minus the square root of negative 18. Okay, now we get to use our new skills. Okay? Okay, that plus or minus the square root of negative 18. Now you could go ahead and bring the 1 over. Actually, let's do that. Let's go ahead and bring the 1 over. Okay, so I get x equals 1 plus or minus the square root of negative 18. Now we see the I there. We see that there's a negative in there, so we're going to have to bring that I out. Okay, but when I do that, what else is in negative 18 other than just the negative 1? A 9 and 2. Good, very good. Okay, so my negative 1 becomes I. What does the 9 become? 3, because they're taking the square root of 9. Can I do anything else with this 2? No, it stays inside. Okay, it stays inside. So my final answer here is x equals 1 plus or minus 3i on the square root of 2. Okay? Okay, can I erase? Now, as promised, I'm going to do the quadratic formula. Quadratic formula. Now, this is a situation where we've got a negative b and we're going to have to simplify. Okay, so this is a great one to look at with the quadratic formula. What's my a value? My a value is in front of my x squared. 1, good. What's my b value? Good, we're going to have to watch that negative 2 because it can cause us some problems. What's my c value? Good. Okay, so I have negative negative 2 plus or minus the square root of b squared, and b is negative. When I square a negative, what do I get? A positive. So be careful. That's a very common mistake right there. Very common. Minus 4 times my a value, which is 1. And then times my c value. What's my c value? And that is all over 2 times a. Okay, so first area that students make mistakes. Do you see how I've got a negative negative 2? What's negative negative 2? Positive. Okay, so that's going to be positive 2. Okay, students miss that. Okay, remember a double negative makes it a positive. The second place students make mistakes is that negative 2 squared. What's negative 2 squared? 4. Okay, then I have negative 4 times 1 times 19. Okay, 20 times 4 is 80. So what's 4 times 19? If 20 times 4 is 80, what's 4 times 19? Some mental math there. It's 76. 76. Okay? If you're confused, just do 19 times 4 off to the side. 4 times 9 is 36. 4 times 1 is 4 plus 3. There you got it. Okay? Okay. Then I have 2 on the bottom. Okay. Now, I've got 2 plus or minus the square root of negative 72. Negative 72 over 2. Now, I know that 9 times 8 is 72. Okay? But 8 has a 4 in it. So 72 is not a terrible one to do at factor tree. Because what is 36 times 2? What's 36 times 2? 72. So your perfect square factor of 72 is 36, not 9. Okay, so be careful with that. So this one, because we know 8 times 9 is 72. So then I can have 4 times 2 and 2 times 2. Okay, so you've actually got a set of 3s and a set of 2s that you're going to need to take out. Whoops, I shouldn't have done that. Okay? So you got to be careful with that because our biggest perfect square factor in that negative 72 is 36, not 9. Okay, so I'm going to write that down for us because we're going to simplify now. So I've got 2 plus or minus the square root of negative 1 times 36 times 2. Okay, so then I have 2 plus or minus I. What's the square root of 36?
6.
Good. Okay, am I going to be able to simplify?
Yes.
Okay, so I'm going to simplify this number. 2 goes into that number once. 2 goes into 6 3 times. 2 goes into 2 once. So my answer here, my final answer here, is 1 plus or minus 3i on the square root of 2. Now, I don't think you will hear me say very often that in this particular problem it's easier to do completing the square. But because of that simplifying that we had to do over there, in this particular problem, I think it's easier to do completing the square. So just kind of be aware of that. And I did both. I did completing the square and the quadratic formula. Okay? Okay, so here we go. Here's my last one that we're going to do today. I would do this one by quadratic formula. And the reason I would do quadratic formula is because of my a value being 2. My a value is 2. So I am going to identify my a, b, and c. So I'm going to write this down, negative b plus or minus the square root of b squared all over 2a. Okay? My a value is 2. My b value is 12. And my c value is negative 5. Okay? So here we go. Negative b okay, plus or minus the square root of b squared minus 4 times a times c, and c is negative. So anytime that I have negative numbers, I always put them in parentheses. Okay, and that is all over 2 times a. Okay? So when I simplify, I get negative 12 plus or minus 12 squared is 144. Negative 4 times 2 is negative 8. Negative 8 times negative 5 is positive 40. Okay? So then I have negative 12 plus or minus the square root of 160, nope, not 164, what? 184. And my guess is there's a 4 in 184. Okay? That's my guess. And I could do the factor tree, but I'm going to do off to the side. I'm going to just see if there's a 4 in it. 4 goes into 18 4 times. 4 times 4 is 16. Okay. 4 times 24, or 4 times 6 is 24. So it does. I do have a 4 right there. Now, 46 doesn't have any more perfect squares in it. So I'm just going to break this down to negative 12 plus or minus the square root of 4 times 46. I'm going to take that 4 out. When I take the 4 out, I'm taking the square root of it, so it becomes what?
2.
Good. So I've got 2 on the square root of 46 over 4. Okay. I simplify. 2 goes into 4 twice. 2 goes into negative 12. Negative 6. And so this is my final answer right here. Negative 6 plus or minus the square root of 46 over 2. Okay? Okay, I will see you guys on Friday.